Hi everyone and welcome back to my channel, #analytics. For this demonstration, I will show you on how to code a Naive Bayes model using the sklearn library. Using an sklearn library, you don't need to compute the step-by-step procedure on how this Naive Bayes model will be calculated. So we'll call the model. But if you want to know the details on how this Naive Bayes perform its computation, then maybe you can check it out in another material so that you understand how the calculation arrive in the Naive Bayes model. Okay, for this demonstration, so as you can see, I'm using a Jupyter notebook. And to do our model, so I will show you our data sets. So we'll be working with these attributes, as you can see on my screen right now. So I have academic performance.csv, and I have 4 attributes. So I have laid down all the grades here, and these grades are categorized to 3 categories. We have competent, capable, and challenge. So now let's go back to our Python environment. So let's start the coding. So since we are working with tables and rows, so we need this library pandas, and we assign our library as PD. Then we will be also working with arrays, so we need this numpy as np, and also we need this sklearn model, sklearn learn model selection for the splitting of our data. So we import this particular class train test split. Then use our library for our Naive Bayes algorithm, but that there are 3 types of Naive Bayes: the Gaussian, the multinomial, and the Bernoulli. So for this demonstration, we'll be using a Naive Bayes Gaussian. Okay, Gaussian, assuming that our values are normally distributed. If you are familiar of statistics, you know what is this normal distribution. And now we have also used, after we have applied our model to a particular data sets that we have also to check the matrix of evaluation for this model. So we're checking the accuracy. Okay, so we'll be checking the accuracy. So we need this matrix. Okay, then import matrix. You can also do some specification of your matrix if you want to check the accuracy and the confusion matrix. Okay, so then you can also use this one, either of the two, that matrix, if you want to specify a particular class accuracy score and confusion matrix. So you can do that. So we can comment this one. We have already established our libraries. Then now let's proceed. Oh no, run. So we have here, I have problem sklearn matrix. So accuracy score, confusion matrix. Okay, run. Okay, there we have it. Then we will now reading our CSV file. So we use our pandas, or represented by a variable PD, and we read that function CSV, and the name of our file, if you remember here, academic performance.csv. So then you have to type academic, making sure that you correctly type it. Okay, CSV. Then we will store that in a new variable, data set. So that's our data set. Then run. Next is we're going to identify our x values and y values. So going back to our Excel, so this would be, okay, our x values, and this would be our y value. Okay, so let's locate this. Okay, then going back, we will assign our x, okay, values. So we have to call our data sets, our Excel file, that then we have to locate the indices. Okay, then square bracket. Then we have to our from 0, this column is 0, then negative 1. So meaning we will not, if we did this one, we will not including this part. Okay, this part. Okay, let's go back to our, okay, code. Then of course, then we assign our y value data set from our data sets. Then we look into our indices. Then colon. Then so when you the index, since this is array, so we start with 0, 1, 2, 3. So therefore this is 3. So this is 3. Then run. Then to check it out, if we correctly store a particular value, this attributes to x values. So let's run our x. And there we have it. We store the English, the math, and the science. Then for our y, then run. So we correctly store this particular column in our y values. Okay. Then after that, we need to split our data. Of course, we have to use our train test split class. And in the train test split, we have to call out our x value and y value. Then we have to identify the size of our testing data set. Say 0.30%. Then we pick up those 30% of our data set starting with 0. So which means, okay, that what we have 132 here because we start with 0. So 30% of that is 40. So 40 rows. But since we randomly pick those 40 rows, so we did not know. So what are the 40 rows? Then we will store this, of course, to our we assign that x trained for our training data sets, and our x for our testing, as well our y value for our training data sets, and our y for our testing data sets. So this is the code when we split our data. Then run. Let's check if it is correct. Then okay, we don't have problem with that. Since we have already split the data, now we will use our naive Bayes algorithm. So since we're using a Gaussian, so this is our object, okay, Gaussian naive Bayes as one of the types of the naive Bayes model. Then we will store that into a new variable that hold that particular object. Of course, we have the parameters, so which means this particular, if you look into the inner part of this model, there's certain calculation. So for this demonstration, we automatically use those computation here, so we don't need to do the or show the computation, how the Gaussian model will be computed. So we will call that already here in this Gaussian naive Bayes model. Then we will store that in our new variable. Then, of course, we will fit, of course, our model to our training data sets from our X values composed of English, Math, and Science. And for our Y value are the category competent, capable, and challenge. So that will serve as our training data sets, the 70% of our training data sets. Then we run this if we have already stored our Gaussian. Okay, we have already stored that. Then next, after we have used our Gaussian model, so let's now check the prediction. So since we have already our variable for our Gaussian, then we do the prediction. We call the prediction function, and we will predict the X or the testing data sets that is 40 rows. So we have 40 values here. Okay, then we will store that into a new variable. Okay, Y predicted. Okay, run that. Okay, so we don't have any error for this. Let's try to generate the predicted values for those 40 testing data sets that we selected randomly here. 30% of 133 is 40. Then we run it. Then if you, okay, this is the prediction. Okay, if you count this one, these are all 40. 1, 2, 3, 4, 5. 5, 10, 15, 20, 25, 30, 35, 40. Okay, these are the 30% of our testing data sets. Okay, the prediction of our English, Math, and Science. Then now from the our model, of course. Then let's try to check the accuracy score of this model. Okay, type accuracy score object, then our parameter, the actual. Okay, this actual is we are the one who assigned the labeling, the competent, the challenge, the capable, and the challenge, and the Y predicted of our model. Okay, then multiplied by 100. Okay, that's how the let's try. So we have 85. Okay, so we have 85, and that's a good model. Then of course it's important for us also to know the classification report. Let's print it out, and the confusion. So for us to check the value of our precision and recall. So let's try print, and I'll discuss to you what's that precision. Precision are those data that we actually label. Okay, and since we're using the Naive Bayes model, then it will generate the precision and the recall of our Naive Bayes model prediction. So we'll be using the Y, okay, for our, because this particular part, okay, so Y predicted. So from, of course, here, if you go back, so we have the Y predicted here, our X, okay, so it's composed of the English, Math, and Science, and we predict that. Okay, so we have here, and since we have already established our testing data sets here, when we split our data, as you can see here, okay, we have data sets for our training and for our testing data sets. This is the 70% and the 30%. Okay, then let's try to okay, then another matrix of evaluation to print is our confusion matrix. Matrix confusion dot matrix underscore matrix. Of course, same parameter. So we have the Y, the actual, and our predicted by our model. Okay, then run. So as you can see, we have generated the precision. So this is the actual values, okay? So as we label in our data set, so we are the one who label it, and the machine, okay, correctly classify that 100%. And the algorithm that we apply, the Naive Bayes algorithm, we have only 77. Okay, this is the predicted, and this is the actual. So for the challenge, so there's some 50% of the label are correctly classified based on our label that we assign. Then our precision is 100%. So as well, the competent 90 as generated by our machine, and the algorithm prediction is 100%. So, and this is the performance matrix that we have to look into. Okay, so that you can verify your data sets if you correctly classify that, and the machine of course generate the classification of precision and recall. So the F1 score, so this is the mean of the two, the harmonic mean of the precision and the recall. As you can see, we have 85% here accuracy. Okay, so this is very important to also to explain and understand this particular performance matrix to determine that if our model is a good model or not. Then we will check a new value. Out. This is a new value. You can test a new value of your trained data sets. Then let's try to use our NumPy assigned variable array. Then we will use, okay, for example, 65. I have a grade of 65, and I have a grade of 89 for, this is English. Math and my science is, let's say, 98. Okay, and we will store that into a new variable. So x new value. So why we are doing this? If you have already the trained model and you have a new value to test, so this is the application part. Okay, then automatically the machine will predict that particular values that we feed into our machine. Okay, then let's try to run this first. If we correctly, okay, now we check, of course, our model, our Naive Bayes model. This is the variable that we use. Then we predict that value. So the parameter, the inside with that is our variable. Then we will assign a new variable for the prediction because we have already used the predicted, so we will not use that. We'll use this one. Okay, then run. Oh, the NV model, because I mistakenly typed it's capital. Okay, then run. Predict. Sorry. Predict, then run. Okay, there we have it. Then let's try what's the prediction of that new value in the actual application. If you're going to implement your model to a real application, this is the testing part. Okay, okay, run. Okay, that's belong to challenge. This particular grade belong to challenge. As you remember, we have only 85% accuracy score. You can increase your accuracy score so that the prediction are correctly classified. Okay, so that's all. So let's go back to the code and let's review it again. So you use this pandas because you're going to manipulate your rows and columns, and this is for the array. And of course, we'll split the data. Before we build our model, we need to split our data. We have training data sets and we have testing data sets. So why we're doing that, why we test our data to check if our model is, to check the accuracy of our model, of course. So that's the reason why we have this one. And of course, our Naive Bayes model, we're using the Gaussian Naive Bayes model. So as I mentioned a while ago, we have three types of Naive Bayes model. We have the Gaussian, multinomial, and Bernoulli. And this particular part is to check our accuracy score of our model and the confusion matrix. And we will be calling, of course, our data sets. So academic performance, that's CSV, using this function read underscore CSV and store that in our data set variable. Then we will assign those values to our x variable, as well as our the values to EY variable. So, and let's try to review. So if we correctly store that, so our X composed of English, Math, and Science, and our Y is composed of this particular value. Then this is the code to split our data. As you can see, we declared 30%. 30% of our data sets, we have 133. We start from 0, so we have a total of 133 records. So 30% of that is 40 records. So meaning the 40 records will be used to test as our testing data sets. Then since we have already split our data, now this one is our Gaussian model, and we store that in our new variable. Okay, this is our object Gaussian model, and we fit our training model. So if you remember, 30% yung ating testing data sets, then we have 70% for our training data sets. So, and now let's predict our 30% values from English, Math, and Science, and based from our Naive Bayes model. Then this store in a new variable. Then we run the prediction. So these are the result of the prediction of the 40 values that we have, or 40 records that we have, or equivalent to 30% testing data set. Then we check the accuracy. Of course, we check the accuracy of our model. So we have 85%, and to check on the details of it. So we have also to look into the precision and the recall. The precision, okay, and this is the actual label that we did and run by the machine, and understood that this is 100%, and our recall uh, by using the algorithm, the Naive Bayes algorithm, it will classify only the 77%. Okay, same with this one. Okay, and the average is 85. Okay, since we have already built our training model and we test our model, and the accuracy performance of our model is 85. If this will be applied in a real scenario, so we have already the model, and let's try to input a new value and check the prediction. So this is the code to predict the new value. So we have our Naive Bayes model, then we call out our predict function here. Inside the parameter is contains the array or our values. Then we run, okay, then this is the prediction. Okay, that's all, and thank you for watching.